Right, today we're going to look at mains electricity, and we're also going to open up a plug and look inside and see what's inside the plug. Right, so let's start by looking at the two different types of current then. So we've got alternating current and we've got direct current. Starting with direct current, this is the type of current that we've been looking at so far. We've been looking at current fed by a battery, the potential difference provided by a battery or a cell, providing direct current. So direct current just means it's going to flow in one direction. The current, it does not change direction, it just flows in one direction through the circuit. And that's what we've been dealing with so far. Our analogy for direct current is just, say, water flowing through a pipe. Yeah. Now, if the analogy for direct current is water flowing through the pipe, then the analogy for alternating current means is going to be water flowing forwards and then backwards. It's constantly switching direction inside the pipe. Yeah, so it's constantly changing direction. That's why it's called alternating. What does the word alternating mean? It means constantly changing. Yeah, so it's constantly changing direction forwards and backwards many times per second, and that's what alternating current does. It changes direction many times per second. When we talk about mains electricity, we are dealing with alternating current. Yeah, we are dealing with the electricity that you get in your home through your plug sockets is delivered as alternating current. Okay, it's delivered at 230 volts. And I always make the same joke when I talk about mains electricity. I always say it needs to go and see a dentist, yeah, because it's 230. Do you get it? Yeah. So I always talk about 230 volts, and then also it changes direction and then changes back again 50 times every second. So 50 cycles every single second, or 50 hertz. Yeah. So it changes, it goes forwards and then it goes backwards, and it does that 50 times every single second, and that's what mains electricity is. Okay. Right, let's open up some plugs and let's see what's inside. Right, so before we look inside a plug, let's have a look at the wire. Okay, so this is the wire that goes into plugs. Yeah, so this is what we call a 3-core wire. 3-core because it's got 3 different wires in it. Okay. Now we've got a brown wire, we've got a yellow and green wire, and we've got a blue wire. Let's start by talking about the blue wire. Our blue wire is our that's our neutral wire, and then we've got the brown wire, which is our live wire, and we've got the earth wire, which is the yellow and green wire. So let's look inside a plug and we can talk about what these 3 wires are for. Right, now here is my plug. Okay, so if I open it up using a screwdriver, you can see inside those 3 wires, okay, and where they connect. The one at the bottom left, then, that's our blue wire. The blue wire, or our neutral wire, is always at 0 volts, and it doesn't change from 0 volts. Yeah, that's the, and then we've got the brown wire here, okay, that's connected up in the top right. That is our that's our live wire. Yeah, live because, and it's brown because if you touch it, that's the color your pants will go. Yeah, I'm kidding, I don't actually know why it's brown, but it's brown, and it's at 230 volts alternating current. That's where the electricity goes into the circuit, yeah, through this pin here, and then it goes out of the circuit through this blue neutral wire, out through this pin here. And the top wire here, our top wire, the blue and the yellow wire, that's our earth wire. That's also at 0 volts. The reason why we have an earth wire is if we have a fault in the circuit that might say, let's say a metal casing or a metal part of your device suddenly becomes live somehow, maybe the live wires touched it, then the electricity will flow out through this earth wire rather than through you into the ground. Yeah, so it just makes it much more safe. So we've got the brown wire, electricity goes in there, 230 volts. We've got the blue wire at 0 volts. Those 2 wires are what completes our circuit. 230, 0 volts, potential difference of 230 volts. Yeah, earth wire, top pin here. Okay, this is what protects us in the case of a fault in the circuit. Okay, we've also got a fuse here Purpose of the fuse is, let's say there was a power surge. Yeah, if there was a power surge, lots of current suddenly going through your very expensive television, the fuse will break before your TV does. Yeah, the fuse, 10p fuse, is going to break before your £1,000 TV, which is always good. Yeah, it's like a fail-safe device. It's designed to break first. Okay. Right, so that's the plug then. I will see you in the next video.